Let me describe how the software works briefly. Basically, you have to give it a file with the coordinates for the shape of the surfboard, the profile, and you have to tell it what the rocker is along the bottom, and you also have to tell it how thick the surfboard is, the distance from the rocker bottom to the top at each point. The bottom of the surfboard could have various bottom contours. For example, it could be a single concave, it could be a double concave, it could be V-shaped, whatever. You have to put in the coordinates of these contours, and you need to tell the software where these contours exist. So then what it does is it basically takes the contours and raises them up vertically so that they sit on the rocker of the board. And if the contours change shape, the software will blend them together smoothly. You have to tell it the contour shape on the top of the board, and you have to adjust the height of the contour to match, the top of the board. So these are going to be, something like this. Okay. Then you need to scale each cross section to fit the profile, right? That's about it. The software puts out a graphic file that I can display. For example, this is the top of the board, and the software will also display the bottom of the board, or in this case the top and bottom are displayed together, and you can see the contours going across the top and the contours going across the bottom. Okay, so basically along these contours there's a bunch of XYZ coordinate points that are spaced about 1/8 of an inch apart, and all you have to do now is use G-code to do linear interpolation moves between adjacent points across the contour. And then after it finishes one contour, it moves along the length of the surfboard 1 inch, comes back the other way, mills the other contour. So it zigzags back and forth in a serpentine-like manner to do the top of the board. And then you flip it over and do the bottom of the board. Yeah, so here's the electronics. Here's the power supply. Plug it into the wall and it puts out 24 volts of DC up to about 8 amps. And that's plugged into the CNC board that you can buy for $120 from Open Builds. Let's see, it has a USB cable coming out of it to hook up to the computer. There's 3 stepper motor cables that input to the 3 different axes on the board, and each axis also has a pair of wires to control a limit switch. There's a few more wires coming in for reset and power on and off, for example. So that's about it. Here's the mill. So it's got this steel frame that runs the length of the surfboard up to about 10 feet. It's all inside of a shed. And on top of the frame is this square rod aluminum track. And then there's this platform that goes across the width of the surfboard up to 30 inches, and that platform rolls on the aluminum track with these skateboard wheels that have been milled out with a square slot. So this entire platform, which is the y-axis, travels up and down along the x-axis. So it travels by this chain that's attached to one end of the shed, comes underneath one spinning sprocket, around a motor-driven sprocket, underneath a third spinning free spinning sprocket, and then chain runs down the length of the shed attached to the other end. The central sprocket is driven by a stepper motor that's back here behind it. So when that motor turns, the entire Y-axis platform moves up and down 10 feet on the aluminum tracks. Okay, so on the Y-axis you have another platform sitting here. This one's driven by a threaded rod that runs through it with a threaded nut. And that rod is driven with a stepper motor at the end. And the platform moves on these linear bearings that move on these polished steel rods. So that entire platform moves back and forth 30 inches across the width of the surfboard. And it carries with it the Z-axis, which is the vertical axis. This has its own stepper motor, which drives another threaded rod through another platform that holds the router. And again, linear bearings on polished rods. This guy moves about a foot up and down. You can see the router bit. Okay, so this entire thing can move along X 10 feet, across the width along Y 30 inches, and up and down along the Z about a foot. And here's the limit switch. On the end of each axis, it's just a contact switch. That serves as a limit protecting switch that'll cut off the system if it crashes into the end of the travel. The router is controlled by a computer. I'm just using my Mac laptop. You can also use a PC. And it's running a program called Universal G-Code Sender that sends the G-code into the electronics to drive the mill. So I'll show you the mill in action on a piece of test styrofoam. It's going to mill out one or two cross sections of the surfboard. So what it does is it mills out each cross section across the width of the surfboard, and they're about 1 inch apart along the x-axis. And so there's ridges of foam in between the cross sections that'll be removed later simply by using a power sander. It's just much faster to mill a cross section every 1 inch rather than milling the entire surface of the surfboard. It would take too long. Okay, you'll see a few cross sections being milled in a moment.